All right, welcome back, everybody. This is the last week of class. Kind of surprising how fast things go by, but I hope you've enjoyed class so far. I'll have a little bit more about sort of following up on what we can do sort of as an end of the class show and tell in just a minute. For those of you that are new to my classes, we do try to do that usually a couple weeks after the end of every class, just so that people have time to sort of play with things and maybe ask me questions about projects they have in mind. So we'll try that probably earliest July. We'll sort of see. So I'll send out a poll for that in just a minute. Today is going to be a little bit of a grab bag of stuff based on some questions people had before, and then just I did get partially the way through the rewriting stuff that I said I would last week. So we'll look at that this week as well. Some interesting things, some difficult things. I'll talk about all that as we go through it. Yeah, so I think we can get started, unless anyone has anything that they made this week that they want to share. I didn't see anything on the Slack channel. All right, I'll go ahead and share the deck for today's class. All right, there we go. All right. So as I mentioned, first things first, show and tell. So we will do a show and tell in a couple weeks. I added a link here for signing up. This is again just a sort of poll about when might be best for folks. So please, I would say in the next couple days, please fill it out, maybe during break if you have a chance. Essentially, like any time in the evenings or any time on the weekends, I'm free to sort of like run the presentation. We usually do it over like a YouTube live stream, so you invite your friends, whoever else you want to attend. And again, this is very much, first off, it's very much optional. You don't have to attend if you don't want to. Second, it should feel pretty low key. Like, don't feel like you need to make some fancy deck to present. If you are still working through a data set, you didn't get around to actually training anything or making anything, that's fine. Show what your data set is. Yugaso, I think, in the previous session showed a data set she was working on, and I thought it was pretty cool. I think it's really great to see ideas behind data sets, all that sort of stuff. If you worked on little bits and pieces of stuff from various projects throughout this week or throughout the past 7 weeks, share what you made. If you made something you're like, I don't really like it, but here's what I learned making it, that's cool too. Like, just share what you learned. That's sort of the whole point of the session, is to sort of talk about what we made and where we failed and that sort of thing. I find that these sessions are a good way just to sort of give you that last kick in the butt to sort of work on something. Since I know it can be a challenge to sort of stay on track week to week, hopefully this gives you a couple weeks to sort of go back through all 7 weeks, figure out what you were really interested in, or maybe something you want to explore more, and then begin to play with it. We will still continue to do co-working sessions up until that time. So if you are working on a project and you get stuck, first off, you can always DM me, but second, you can also attend one of those co-working sessions and we can work through some things together there. So again, this should feel low key. If you are not a public presenter, that is totally fine. What you can do is record a video, share that video with me, and then I can play that video during the show and tell. So, this is not to cause anyone anxiety or anything, but it is just sort of celebrate the work that we've done over the past number of weeks. A couple other notes. There's been a lot of stuff that's been going on in the Slack channel this week about the Colab notebook for the StyleGAN training having been broken. I'm still trying to debug a little bit about what's going on there. I think I fixed it by just tying it to the version of PyTorch that I know works. So I've updated the notebook to include that. You might want to go back and just grab the line. So the line from that notebook actually here, just pull it up here. So if you go to this, the notebook that we have sort of have everything in. At the end here, all I've done is I've added the versions of Torch that we need to install. Colab updated to the latest version of PyTorch, which is 1.9, I believe. If we tie it to previous versions, I haven't had any issues training using this. This does take a handful of minutes to install the correct version of PyTorch, so it probably adds a handful of minutes, 10 minutes or so, to getting your notebook set up. If I figure out what else is going on there, I will try to resolve that. It seems like it might also be something to do with storing these files in Drive. There might be some caching issues where using PyTorch 1.9 plus this is getting messy. But I know this works, so if you try this, this should work for you. If you do run into issues, please post in our Slack channel, and I can try to debug it. The other solution that people have found is if they delete the Drive folder itself and reinstall it using this process, it also works, but I would prefer not to have people delete lots of files and potentially lose models. So start with this, and if that doesn't work, we can figure out a way around it. And lastly, just today, the makers of StyleGAN announced a new version. I feel like every time I teach this class, there is some new version of StyleGAN that comes out, and I have to quickly figure out what's going on with it. The good news is that since this is the last class, I won't be covering it. The other good news is that they haven't released the code yet for it, so we can't even use it. So the code will be out in September. But if you are interested, the paper is up, as well as some demo videos and some other things. So I actually think this is kind of a great, I'm really interested to sort of see where this goes. One of the things that I've noticed, actually this is not the right link. Where is, here I can find it in our Slack channel. This is the link to the paper. I wanted to pull up one of the videos from the session. So instead of calling it StyleGAN now we're calling it alias-free GAN. I don't know. Maybe it'll just be StyleGAN AF or something. I actually think this video is a really great example of something that we've been talking about in this class, which is that sort of saran wrap look of noise sort of sticking. So if you play this video, you'll sort of see here, this is like the worst I've ever seen it, but there's this like noise texture where as the face moves, the sort of texture itself sort of stays static. You might not be able to see it over Zoom, but if you take a look at this video on the web page, you'll sort of see that it has this interesting effect where like the noise is sticking and everything else is moving around it. In the past, last week, what we started to do was actually to interpolate the noise so that the noise moves alongside the image, even if the actual noise isn't correlated to the face correctly. What you'll see here, what they're doing is they're learning like basically how to avoid this completely. So not even hacking around it, they're doing some other things with it. So I think it's really interesting. There's a lot of other stuff. It sounds like they're starting to learn about these models. We've talked a lot of this in this class about those noise vectors, and I think that they're starting to learn those noise vectors are somewhat problematic. So they're finding ways to work around that, amongst other things. So I think this is really interesting. We'll sort of see what happens. Obviously, when the code is released, I'll have some updates on it. But yeah, I think, they're always making progress on these things. So it's kind of fun to keep up to date on it. And again, maybe in a future sessions, I'll be teaching this new version for anyone that's interested. So yeah, never a dull moment in machine learning world. All right, so this week we'll probably be spending like the first half of class or so looking at the rewriting tool, module, I don't know what to call it. It's called GAN rewriting, and we'll look at it for the next hour or so. We'll say there's a couple issues where it's hard to run on Colab, but I'll talk about that in a minute. So I've got some examples, or like I owe everyone a tutorial on how to get this set up on something that isn't Colab, which I will do over the next week or so. The concept of rewriting, and this is something that we've sort of explored mostly in this class, like over the past 4 or 5 weeks, is we really want to start to gain more control over our GANs, right? Like we want to be able to say like, hey, do this, but do this in just this section. Or it'd be really great if I could convert this flower from yellow to red. And we looked at a number of tools to do that, stuff like style clip, stuff like feature vectors, gaining more control over things through network bending or other parts. But it's never been easy. It still remains like sort of one of the core challenges, right? And I think realistically, like the holy grail of these tools is if you could generate almost like a Photoshop style image and then be able to sort of like through some sliders be able to edit things in a way that makes it semantically correct, but also like very from an image perspective, like it feels coherent. And so in the past, we've tried stuff like feature vectors, which we had to like we've had to dig through a bunch of different options to try to like make them human readable, give them descriptions. Rewriting sort of works with the concept of like, what if we were literally doing something like cutting and pasting in Photoshop, and then we let the model try to figure out how to actually do that. So we'll take a look at this now. So I learned a lot. The author of this paper, David Bao, has a really great, it's like an hour-long lecture through an MIT class. If you're really interested in this concept or just about learning more about essentially forensics for GANs or how to like sort of understand GANs more, I highly recommend watching this. I'll sort of cover some of the high-level details in this class, but if you're really interested, I definitely recommend giving this a quick watch. I'm kind of embarrassed to admit that I haven't really covered a lot of David Bao's work before in this class. He's since at least 2018, 2019, been doing some really, really interesting work. His paper before GAN rewriting was called GAN dissection. And I kind of almost want to go back and look at that because I think there's some really interesting ideas and motivations in there. And what you'll usually find with most researchers is they kind of have a train of thought that follows all their work. So when David Bao, I believe he's still at MIT as maybe a PhD student, when he started with GAN dissection, the idea was just like, how can I better understand how a GAN model works? And now he's sort of in a place of like, now if we can understand how a model works, can we actually manipulate it in a really fascinating way? So lots of really great information in this video if you're interested. So as a recap of, I guess, last week or maybe the week before, remember that our StyleGAN model has a bunch of layers, right? It goes 4, 8, 16, 32, 64, 128, 256, up to 1024 if that's the size of our model. But also remember that inside of each of these layers are a set of neurons, and these neurons have individual weights, right? They're assigned a value, and that value can determine what images or what changes happen at those layers, right? So we send in our vector to the 4x4 layer, it gets upscaled, and each upscaling has a process using these neurons to change that upscale. And that kind of makes sense, right? If you have a 4x4 pixel image, trying to upscale that to 1024, there's like a million things that you could do with, say, like, a couple different shades of yellow. So what we do is, as it gets scaled up, features change, other layers change, that sort of thing. So what David is doing in GAN dissection specifically is he's looking at what each neuron controls. And he's doing it through a process of, probably sort of some brute force machine learning tools, changing the weights of neurons, outputting the image, and then like determining what changes, where the biggest change in that field is. So here's an example of layer 5 neuron 304. This is using a church's model. There's a sort of big data set of church images, and what they found is most of those images have also been stolen from Shutterstock, including the watermark. So the GAN model actually learned to recreate the Shutterstock watermark. So the question with sort of GAN dissection was like, can I find what neurons are most affecting the watermark, and can I change those neurons to actually essentially alter the watermark? So he went through there. He found that some of these neurons were just affecting sort of the middle of these images. Other ones were affecting sort of the middle and the bottom, right? So I guess Shutterstock has this like image tag that is on the bottom of their images. So you can sort of like see that, one of these neurons is affecting sort of this middle range, another is affecting sort of the larger scale middle range, but also the bottom. What he found is, these are given weights, right? They're given weights of negative 0.12345 or positive, 0.3576. And what he found is if he zeroed those weights out, like just completely remove them, he could alter the look of the image. So here we have the exact same sort of vectors on the left, this being the default sort of church's model. And on the right, what happens when he zeroes out those neurons that specifically affect the watermark. And if you look here very closely, you'll see that there's actually some entanglement, right? So if you look here, we've got this little spire, and when we remove that, the spire kind of disappears or maybe changes color or shape a little bit. So it's not perfect, right? All of these models, because even though they're a very, very large sort of weight space in terms of like just the number of neurons that are available in them, they really can't contain everything. So there is still some entanglement as we do this, but I would say, like, if you were to look at this image and look at this image, you would kind of be hard pressed to immediately tell big changes. And overall, I would say, like, you know, people are going to prefer an image that doesn't have the watermark in it, or doesn't have this bottom sort of image tag metadata on it. So this is really interesting, right? Because what it says is that if you find, I think what he said is there's something like 30 neurons that he associated with this watermark, and just zeroing them out gave him almost the exact same image without the watermark. And this is really interesting conceptually, because it means that, you know, we can sort of, even with a model trained on a lot of images, we can still alter it enough to make still realistic images, but just remove some features, right? And I guess you could sort of say, like, these are maybe feature vectors in some ways, right? Those 30 neurons could essentially be a feature vector, where now we could maybe add a watermark to every image or remove a watermark from every image. So it's really interesting from a concept. One thing I will note is this is kind of different than a feature vector, because a feature vector is tied to our actual input vector, whereas this is editing the neurons in a layer. So it's a little different, similar conceptually, but from a technical perspective, a little bit different. So as we move into the actual GAN rewriting process, what he's taken is basically, now he has a GUI tool that says, well, what if I could highlight this and say, like, okay, I want, you know, just find all these images with watermarks, and then maybe compare them to images without watermarks, and then let the machine try to figure out, like, what to zero out. And that's what GAN rewriting essentially does. Or, like, you know, say that you want to go from maybe I want clouds in the sky, and I want to remove clouds. So I want to say, like, okay, here's a bunch of clouds, but here's what I want the sky to actually look like. And then the model could figure out how to do that. So I went through a couple examples this week to try to just to sort of play with this to understand exactly how it works. So with my flowers model, one idea I had was, like, I really want to take this flower, right? Can I take this flower and paste it over this white flower and actually change the image, right? So can I actually create a new image from this, right? So just, like, take a red flower and put it here instead. So I went through some options here, and the key here is to play with the layers first. So we'll look at some layer options. So there's also a lot of nomenclature, and we'll go through the GUI to sort of explain what each thing does. But you'll often find that there's, like, a copy, and then there's a target, or a copy and a paste. So we'll look at that, and I'll try to help break some of that down. But I went through this and sort of played with this. So you can set your layers in this model. Again, we'll look at it in just a second. So what I did is I copied this section and I tried to paste it here. And when you do it in layer 4, what you get is this, right? So you see, like, there's some red here, but the image itself is kind of, like, blurry and gnarly. So what I had to do is I actually went through pretty much every layer one by one to try to figure out what I thought would be the best layer to actually alter. Start with layer 4. I jumped ahead to layer 8. This is really, really fascinating to me, because look at this. So I took this flower and put it in this location, and what I get on layer 8 is still a white flower, but all of a sudden my edges are shaped like this flower, right? It's got the pointy edges. So this kind of says to me, like, okay, maybe layer 8 doesn't affect color, but it does affect shape. And that means, like, now maybe as I begin to play with this more and more, I'll find other places where I can edit things to create this effect. I moved up to layer 10, and all of a sudden I'm starting to see almost exactly what I want, right? Which is this flower pasted here by itself in red. Now, one thing you will notice is there's some other funkiness that is happening around here. I think that has to do with the drawing tool in this GUI is a little crude. You've got, like, a 20 pixel paintbrush, so I probably, like, clipped a little bit of this. But I think it's really interesting that just here, adding this in works. And then lastly, I went up to layer 12, and you'll see my colors got more accurate. One note is that there's a process of just cutting and pasting, and then there's also a process of training the model, or like having the model learn this representation. For whatever reason, when I set it to layer 12, the execution of like training them, like having the model learn this representation through an error, I've yet to figure that out. So I think you have to stick between like up to layers 10. I think 10 might be the max, but for whatever reason, this kind of worked. So overall, I think this is really, really interesting. I don't actually have an example of what happened. This is kind of bad on me. I should find this. I'll paste it in, or I'll drop it in our Slack later. When I actually did the learning representation, right? So this is a brute sort of force copy and paste job that happens through these layers. What this does says like you've basically modified this particular image in its weight representation, but it isn't really like the model can't now reproduce this. So you have to do some optimization to actually make this happen, almost like a projection. When I actually projected this or like did the optimization process, all my white flowers turned red. So there's also a little bit of like, sometimes you think what you're doing is just one thing and what you're actually doing is affecting a bunch of other stuff, right? So there's entanglement in these things. I'll grab an image of what that looked like and paste it in for people to see. But just know that this isn't a perfect process. I kind of liked the representation of just like pasting these activations in. This isn't really changing the model. It's sort of changing like a single image in the model. But I like the representation of it. I won't share the horror show images that I've been sharing on Twitter and Instagram, but I did this process for other things as well. I'll save Grant, from that horror show. But if you are interested, I can link you to it. Where I was pasting people's mouths into people's eye locations using this process alone. So it wasn't actually changing the model, and you get some really interesting, creepy looking things that happen. I'll demo a little bit of how this works when we actually get into the GUI, so we can see what it does. And I know like something that Naoko and I have talked a lot about, which is like a lot of these tools really rely on sort of an understanding of realistic images, right? Changing flower color or adding hats to horses, that sort of thing. So I was particularly interested in what we could change with these models by with more abstract models. So this is one of my more abstract images. So on the left here, you'll see there's a bunch of these triangles here in this location. Right, so there's a triangle here, there's a yellow triangle here, there's a yellow triangle here. And what I did is I took, I guess, some like blue trapezoid or something and tried to paste that into this location. And then I ran the optimization function. What you'll see is it actually turned this yellow triangle into more of a blue shape. So you'll see it sort of got erased here. It's more or less erased here as well as here. So again, even with abstract models, you still need some concept of like, what am I doing across the model? Am I removing something? Am I removing a shape? Am I changing the shape's color? Am I changing something else? But it does work. And what I think is fairly interesting here is you'll see that these three images changed quite dramatically, but this one only changed a little bit. You can kind of see some of the noise here and here. So the idea here is like we want to like keep these disentangled, right? We don't want this to affect everything in the model. We just want to affect just the things that we're pointing it at. And this worked fairly well. So I think I think there's a lot of opportunity for this tool to be really interesting and cool. So there's good news and there's bad news. The good news is that I do think this is fun. I think there's a lot we could do with this. The bad news is that the GUI does not work for 1024 models on Colab. Apparently Colab has like an issue with how the GUI is built, and it throws an error if you try to do anything with really large models. So I got it running on my local computer because I have like a Linux machine. If we have time at the end of class, I might show what it looks like on Linux, just so people can sort of see that it does work with these custom new models. What I will also try to do is this week I'll try to record getting this running on Paperspace. I previously have taught with Paperspace, which is like a rentable GPU. The nice thing about Paperspace is it has a desktop sort of virtual window, so you could actually use the GUI tool in Paperspace. So I almost got that running and working this week, and I just ran into an issue or two here or there. So I'll try to fix that this week, and then I'll post a tutorial on how to do it. So if you do have a 1024 model that you want to alter, hopefully by this time next week, you'll be able to do that. If you have a 512 model or a 256 model, you probably should be able to use the Colab version today. And also, if you're really interested in this process, training a 256 by 256 model isn't that slow. It like happens relatively quickly. So if you've got a 1024 data set, just like shrink it down using the dataset tools, and then you could train a 256 model really quickly and then play with it in Colab if you're dying to try it. So I mentioned a couple tips here, which is like play with the layers first. Layer determination has a huge effect on like what your actual output looks like. Then we're going to play with the context and learning rate, so I'll show what those look like. But those are sort of the next things I play with. And then lastly, I should mention, this is, as I mentioned before, this is not really a feature vector. What this does is actually modifies the weights in your model, which means you can essentially save out this model, but you don't want to overrate your previous model because you'll lose that model. And I should also mention, like in the case of stuff like removing that yellow triangle, it's going to remove it from every single image in your model, right? So like if you were to say add hats to horses, which was the demo we saw previously last week, if you add hats to horses in that model and you save that model out, every presumably or hopefully every horse that you then generate from that model will have hats. So this is sort of a destructive feature. So it's not a feature vector where you can sort of say like hat, no hat, hat, no hat. This is actually like destroying or essentially altering the underlying parts of the model. The other challenge, which is something I meant to try to, I sort of ran out of time this week. I wanted to try this model, use a slightly different architecture than the traditional StyleGAN model. So the other challenge is that once you've actually saved out this model, you can't just like bring it back into like our repo or into the network bending or into the audio reactive model and use it. I'm actually going to reach out to David and see if he has ideas on how to sort of work around that. But yeah, this is kind of like a one side, it just sort of like sits in its own world, which is the challenge of a lot of these StyleGAN tools is that they can make breaking changes and then it's really hard to move them back into like the bigger ecosystem. So just be aware of that. I will hopefully have that fixed in the next couple weeks as well. So if this is something you do want to play with and you want to generate video and other things with it, hopefully we'll be able to do that pretty soon. All right, so let's take a look at the notebook. Not the right notebook. What did I link to? Where did I save this? Give me 1 second. I'm just going to pull it up in Colab then. So I'll edit that that link on the slides, but there's the file for anyone that's interested. So we'll go through the same process here of just getting set up on Colab. All right. So for the Colab demo, I'm going to use their pre-trained models again because the 1024 model doesn't really work on Colab. Don't use the faces one on Colab. You'll get this error message or just like break and you won't really understand why. So there's 3 models we can look at here. We could also potentially grab something from the awesome pre-trained StyleGAN 2 models if it's 256 or 512 and play with that. For this example, I'm actually just going to use the church model, which I previously showed. Up here, there's also there's a choice between StyleGAN and ProGAN. I recommend just leaving it as StyleGAN, and then you can use church or horse or kitchen as models to use. So you can set this variable. So if we want to do horse, we could do horse by just setting this here. I'll just leave it at church. Next, you need to choose what layer you want to work on. So the thing is, once the GUI is running, it's operating on an individual layer. It can't switch between layers. So if you want to switch your layers, you actually have to rerun the cell to get a new version of the GUI running. There are some notes here that were left in the repository about what's good and what's not. So this example says layer 8 is good for trees or domes and churches and hats and horses. So I'm going to leave it at 8 because that sounds about the right layer that I want to work with churches. When I do this with my own model, I'm generally just like, I play with the layers a little bit and see what I can produce at each layer. So you might want to just alter this and sort of start with like something low, like 6 or 4, and then slowly work your way up to see how it affects images. Next, there's a size variable here. The size variable determines how many image samples it generates at one time. 1,000 seems to be plenty. That's like you get to look through 1,000 images, which seems plenty high for me. If you really want to like see more images, you can crank this up to like 3,000, 4,000. But for the most part, 1,000 seems about right. This also allows you to do some mathematic processes on this to be able to understand sort of actually what's happening in those images. So I wouldn't set this to 100 or 10 because that's probably going to screw up some of your layer designation. So I think leaving around 1,000 makes sense. Lastly, we're going to save a bunch of stuff to some folders here in Colab. I haven't found a need to change these names, but if you want to, you can. This seems about right for me. Okay, so now we're going to just, and the rest of the code here loads up the model and actually sets it up to do this rewriting process. So we'll go ahead and run the cell. Anyway, so basically what we've done is we've loaded in the model. What I recommend you do immediately after this is actually generate some images. So what we're going to do is we're going to take our model and we're going to generate 100 images. And those images are going to be saved in a folder called original samples. The reason I like to do this is I find it's helpful to run sort of a before and after on a bunch of samples, just so you can sort of see how it affects different things. So let's go ahead and run this. So this will create a folder here called original samples, and it's going to generate 100 images. And if I double click inside these images, you'll see I have some churches. That is barely a church being blown apart. Okay, so now that we've done that, now we can actually load in our GUI. The reason you want to generate these images beforehand is you don't want to actually have changed your model, so you can just do that. So now we'll run our GUI. Oh, I feel ridiculous for having made that error. Okay, so now we've got our GUI running, and we can go ahead and start to play with this. So a couple notes here is some of the language. This is clearly not to speak ill of developers, but it's clearly designed by a developer and not by a designer. It can be a little confusing about how to actually make edits. So the way you make an edit is you draw on the interface, and then you will either add to context or add to copy and paste. So I'm going to show you how I've approached this so far this week. I sort of have this idea of like, okay, what do I want to do with this model first and foremost? So one of the examples that is in the paper is removing windows. So what I thought would be good is let's actually just see what it looks like to remove a window. So let's go ahead and paint in a large area of wall. So I'm just going to grab a bunch of wall space. I'm going to hit copy. So you'll see this has now been added to our copy space. And then what I'm going to do is I'm going to come in here and I'm going to remove one of these windows. So let's just remove this window since it's nice and big and in the middle. And we'll do paste. And there's an example of sort of what happens with this. Like, this is the example of where this is just like a purely activation base. We're just sort of pasting this in and letting the model sort of figure out how to smooth it out. So in this case, because I'm using layer 8, it's fairly good. If I were using other layers, I might not actually like the effect of this. It might not actually be removing the window. It might be changing the color of the window or other things. So in this case, you might want to go back and actually edit what layer you're using. So let's actually do this. You might come back here and just change this to like 6, rerun the cell, rerun the next couple of cells, and go back down to the GUI. Because we lost a little bit of time today, I'll just leave this as this. And then what you really want to do then, once you've got this sort of set up, is then you can go ahead and figure out like what other windows should it be looking for, right? So far we've only told it to really look for a window that looks like this, and that can be like somewhat of a challenge. So what I recommend doing is actually just restarting the cell, so you get the GUI as a fresh new version. And then what we're going to do here is we're actually going to use the context mapping. So what this allows us to do is allows us to pick from a number of images where windows that we should be removing are, so that the model can then sort of better understand where these changes should be occurring. So let's remove this window, and then we'll hit add to context. That get added. Add to context. There we go. Okay, so you'll see that as you add up, you're going to layer in a bunch of these images, and it's going to show like the little painted area where you're trying to remove a window from. So let's find another good example of a window we should remove. Let's remove this window. And we'll remove this window. See if there are any other good ones to remove from here. This thing kind of looks window-like, so let's remove that as well. So there's a cool little feature of this, which is that once you've got some context images added here, you can do a search. And what search is going to do is it's going to find all the other images within that 1,000 samples that it thinks sort of match this look. So let's hit search. Cool. So now I found a bunch of other images that it thinks sort of match that. This is kind of just a cool search feature in and of itself, right? Like this could find a bunch of images that are similar to yours or other things. So it's kind of helpful to find this. It's not perfect, right? Like I wouldn't necessarily say like this doesn't look like it has any windows that I actually want to remove. This sort of seemed to just found the image itself or maybe a like neighbor of it. But we can go in here and just add a couple more to our context. And as these get added, there's like an overflow menu, which can be hard to see. So just be aware that that exists. So let's find a couple more windows. Let's remove this window. Now let's see if we got one more here that we can remove. Let's remove this one. I should also say, like, if you're not finding, if for whatever reason you didn't find enough images in this section, you can also search by an actual image. So if you come over here and you look at your samples and you say, oh, I really want image 21, you can go in here and type 21. And then this looks for generally like 32-ish images in total. So you can also do -52. What this will do is it'll load up your sort of like Finder window over here with all of the images you're looking for. Let's see if it found any new ones. Actually, this looks pretty good. Let's remove this thing as well. Here's a good Shutterstock watermark. Let's add that to our context. Okay, so now that we have a bunch of images loaded up in the context as like the machine learning model is supposed to find these sort of patches and sort of know then how to alter these. Now we can go ahead and actually do the process of painting in and copying and pasting. So what I'm going to do is I'm going to grab, let's see if I find some good. I actually think that brick image from the very beginning was one of the best. So let's do 0 to 31. That's what it always starts with. The first 32 seeds, essentially. And let's go and grab this patch of brick. On some kind of big. We'll add it to our copy. And then we'll come and we'll find that other image that had a window that I wanted to remove, this one. And we'll add this to our paste. Okay, so now I kind of have a visualization of what this is going to look like with the copy and then with the paste. And what I want to do now is I want to execute this change across all of my model. And the way to do that is hitting execute change. One note is that this is an optimization process, right? So it goes through a learning rate, sort of like projection. There is down here a learning rate option. I think 0.05 is what the default is set to, and I think that's fairly good. You might want to turn it up a little bit or a little less, but you might want to play with this value. So what I'm going to do is I'm just going to hit execute change. I'm going to see what my results are going to look like, and then we might play with this a little bit more. So see, it's going through this iteration process and it's updating it. So you can see my update did not actually like do the effect that I wanted it to do. This happens fairly often, and there's maybe a couple things you could think about. So one is maybe my context is too diverse, right? Like maybe I've got this change in too many different locations, and I want to focus on just removing a window from like a specific location. Like maybe I just want to focus on it when it's in the center of the screen. The other option is maybe my learning rate is just too low, and I want to crank it up. So actually, let's go down and see. See, it didn't affect this image much either. So the other thing you do is, if you want to see what the original images looked like before you executed this change, you can do toggle original. So you can see it actually made that window bigger in this version. So I can toggle between these. There's a little slow, is a little bit of a, it's not super fast. So clearly this didn't work the way I expected it to. So maybe let's try updating my learning rate. So if you click revert, that's going to revert you back to the original model. So we'll do that first. So here's my original model. Maybe if I turn up the learning rate a little bit, we can see if this helps it at all. So let's make this a 1, and then we'll come back here and hit execute change. And that didn't do much of anything. It almost made it worse. So I think what would probably happen here is my context is too large. I have too many changes in this context, and it's not really understanding what I want it to do. So the best thing to probably do here is just to restart. So just rerun the cell. This is kind of the downside of GUIs in Colab is like they're connected to these cells, and there's like no restart from scratch button or whatever. So maybe let's just try something a little bit more simple. Like let's just say, like let's just work on removing windows that look like this. So we'll do this, paint this one in, we'll go to add to context. And instead of actually like trying to dig through these, let's actually see what the model sees as the most similar images. So we'll hit search. Okay, and here are the images that it thinks are similar. So I guess maybe it's saying like this is, let's add this to our context. Let's do this one. So you can see the windows I'm playing with are a little bit more circular, and they're always sort of in the center of the building in this location. And that just tells me that maybe, I need to be more specific about what I'm actually editing. Let's try this one. And we'll do this one too while we're at it. Okay, so now let's go back to our original image. So we'll take from here, copy, and we'll take from. So another thing is like, you'll notice that this image already has this sort of blob in it. So the way to sort of like switch out of using this one is just like paint in another image and then come back here, and then we'll paint this in again, and we'll use this as our paste. All right, so let's try this now and see if this works better. I honestly have no idea if it will, but let's just find out. Okay, well that did something. It removed our image a little bit, but didn't do a perfect job of it. This is a case of where I might actually want to move up or down in the layer stack, just to sort of see if maybe textures are better applied on like a higher layer. So we went through, and I'm just going to grab a couple more images. So we can sort of toggle between these and sort of see what happens. So it's doing an okay job. It's not perfect. Again, I think this might be the wrong layer for me to be playing with, even though the result here looks good. This is why I've actually hacked this in my own system, where I can actually just purely do cut and copy and paste. Actually, the people with mouths as eyes that I shared was actually done just using this process. You can open this image in a new tab, and I removed all of the like sort of GUI graphics over top of it. So I was just saving out those images and actually altering that. So it's kind of a fun process where you're kind of creating an image that can't really exist in the model, but you do get a nice looking image out of it. So just be aware of that. Okay, so the other thing is, let's say this actually worked perfectly and I want to save this out. If you want to save the actual two images, this pair, you can do that by doing content.test. Don't add the extension here, and then you just hit save. This is going to save out a file called test.json. And if you open this file, you'll see that literally what it does, it has all of the context images, the sort of context keys, and then it's got your actual copy and paste image in here. So what's interesting is this particular version, like you can save out the model, the hard-coded model itself. What they kind of recommend you do is just save out this data and then run the optimization process again. Maybe not the way I would do it, but it's fine as is. You could also then, like, if you're like saving this file down, you know, to your computer, and then the next day you come back to Colab, you can load in that same file with this load function, and then that'll load it in. So you can kind of like pick up and start. The last thing I recommend you do is that you actually, once you've sort of picked the version that you like, you go ahead and run that same process of generating 100 images. And what this will do is it'll create a new folder called edited samples. You could then download these two, or maybe in some other like, maybe in like an application using like Pillow or something, actually combine them to compare the two. I just find this helpful just sort of make sure that like what you're actually editing has been edited. There's probably a lot more you could do with this. This is just like bulk generating 100 images. It probably would be better if you could like pick the seeds of the images, and then you could like cut and paste. Yeah, so just be aware of that. Sorry if my audio is dropping. Hopefully it is recording, so in the recording it'll be picked up fine. So lastly, you can save out the model itself. So what I've done here is I've just saved the model weights. So we'll just run this cell, and this will save out a PyTorch version of the model. There it is. As I mentioned, you can't just like load this into the network bending repo or anything without some modifications. So hopefully I'll probably spend the next couple weeks trying to fix this, so you can actually do this and then load this into another place, but I need to edit some things before doing that. But if you want to back it up, you'll have a copy of this backed up if you want to get to it. So why don't we do this? We'll take a break, and then we'll come back. We'll finish up some other material that I wanted to cover for class, and then if we have time left, I'll go in and show working with a custom model on my local desktop computer. So why don't we take like a 7-minute break? So let's come back at 42 after, and then we'll pick up from there. All right, see everybody in a little bit. All right, so yeah, so I'll do the other, or I'll show my other screen toward the end of class, just depending on how much time we have left. But I don't think I'll need to cover too much other material just yet. So, or like, I think I have enough time to cover this and this other material as well as the other demos. Let's go ahead and go back to our slides. You all can see my screen now, right? The GAN rewriting slide. Cool, okay, great. So Varun isn't here, but Varun had a really good question, which was, he was trying to figure out how to take his projected vectors from our projection class and bring them into the Audio Reactive notebook. And I actually realized this is probably a good moment to just talk about some basic sort of vector and tensor functions within our tools. So one of the nice things about vectors is that they work across any model, right? If you have a vector in the basic, or like my version of StyleGAN PyTorch, and you want to take that same vector the same numbers specifically, and bring them into like a Rosinality version, it'll work. So that's kind of a nice thing because we're loading the same models and we're loading the same vectors, so it's pretty easy to move stuff around as long as you know how to do it. So that we would just go through this Colab notebook and I would talk about a little bit about how this works. These tend to be the functions that I do pretty much every day whenever I'm dealing with machine learning or specifically like moving vectors around. So hopefully people can find some value in this if you're interested in playing with this more. So let me just add this to our chat. Cool. So there is a link. And so in this case, like this notebook will just help walk you through a little bit of detail about how each of these things works. You don't really need to install this repo, but we'll go ahead and do it anyway. And this is lightly documented. So if there are questions about what's going on with these things, please just ask and I'll either tell you or I'll add it to my notebook so it's a little bit clearer. So first off, as you probably saw, like we're using NumPy pretty much everywhere. NumPy is a Python library. It's called NumPy because it stands for number Python or like something number Python because NumPy is basically like a really good library that works with numbers and math. It's very fast in the way that they built it. So pretty much everyone in the Python world, if you're dealing with any math function, you end up using NumPy. And Torch, is obviously for PyTorch. So if you're doing PyTorch, you'll use Torch. If you're using TensorFlow, you'll probably see import TensorFlow as TF. Thankfully, we don't have to use TensorFlow anymore because it's really verbose and really hard to understand, whereas Torch is a little bit clearer. So the first thing, this is sort of a recap of what we did, I guess, maybe in week 3 of class, is we want to look at how to actually make a random number using a seed. The way to do that is to set your seed value as an integer, and then use NP, which is NumPy, random state. So this is going to save this number as our random seed variable. And then when you go ahead, I'm going to comment some of this stuff out. When you make a random number using this same function, you will always get the same value, or at least always get the same value the first time you run it. So the thing to remember about seed values is they help sort of like create a way in which you get the same vector out every time. So if we run this, you'll see that I generated a random seed in the shape of 1, 5, 12, which is z vector. And if I print the shape, so anytime you want to see what size a thing is or whatever, like z.shape is like a thing that I pretty much run all the time to make sure that the shape of my vector is in the right form. And then what I did is I just went in and grabbed the very first floating point number from that z variable. So if you were to actually print just z, so let's actually do this. We'll do this here to down here. We'll do print z. That's going to print out every single value within my 512 dimensional vector. I don't really care about that value too much. I just want to make sure it did print something. So often what I'll do is I'll just print out 0, 0, which is this stack and then the first variable within this. And you'll see here it's written out in the sort of E script, but that actually equates just to this value. So it just tells me that I get a new number there. The reason that I am doing that is also that I wanted to grab a second variable. I want to create one called z2, and I wanted to see make sure the shape was the same, but I also want to check to make sure that the value of this variable or the value of this z and this z are different. So this should give me the second z00 or z200 should give me a different value than this. Let's go ahead and run this. So you'll see my first number didn't change. My second number is different than my first. And if I run this again and again and again, I should always get these two numbers because of this random seed state. So I just keep getting that number over and over again. Oops. So that's the nice thing about random seeds is that the order in which you get them back is always going to be the same. Now, if you want to make more than one z, the way to do that is to just change the shape of this random number generator. So rand_n generates a floating point value for all of these functions. So what this is going to do is it's going to give me 12 z vectors, right? So it'll be 12, 5, 12. And if I print out the shape of that, sure enough, it is 12, 5, 12. And let's say I want to get just the first vector or just the first z from this stack, I can go ahead and run this code. And what that does is it just asks for the first index of the 12, 5, 12, so that I will get that, and I can run this. And you'll see this is in the shape of 512, right? So it's just giving me the 512 dimensional vector from that. So these are some common functions. I will pretty much always run this. I also highly recommend running the print function when you can. Printing out stuff helps you understand what's actually going on. It's really, really valuable. So that's sort of the first step, is just like how to generate some z's in NumPy. NumPy is great, but for our use case, we pretty much always want stuff in Torch. And there's sort of two different processes to do that. The first is to actually convert your NumPy value to Torch using torch.fromNumPy. So if we take these z and z2 values and we paste them in here and do converted z, or like, this would be like torch z, I guess, is a better way to describe this. Torch z and torch z2. So you can just do torch from NumPy. That's going to convert this into a NumPy array into something that Torch can use. And the reason we want to do this is because we'll usually want to stick these numbers on the GPU, and you can't stick a NumPy array onto the GPU. You have to use Torch to do that. You could also create a vector directly in Torch. So you can set the manual seed. So we're setting a manual seed in NumPy is np.random.randomState. The way to do this in Torch is do torch.manualSeed, and then give it your seed value, and then you can create a torch z value. Let's call this torch z3. This will generate a new torch value in that same shape. And if we run, let me comment this stuff out. You run this, you'll see that my torch value is also 1, 5, 12. One thing you will notice is that this is in brackets, whereas the previous shape was in a list function, just with comma or like not curly braces, just parentheses. This kind of tells you this is a tensor versus this being like an array or a list array. Little details like this are helpful to notice if you're like debugging, but it might not mean a lot to most of you today. And then I grab just what the first number of this value is. You'll see here it says it's a tensor value of this instead of just being an output value. So Torch creates tensors, NumPy creates NumPy arrays. The difference is pretty subtle, but it's just helpful to sort of know the nomenclature to be aware of this. And lastly, one of the things you often want to do is create you can also create batches in the shape of things. So we could create a single W vector in our torch.rand using 18 and 512, right? This is the shape of a W vector. So we go ahead and run this. The challenge is what PyTorch usually wants is something that's shaped like this. So what we're creating is something that is this shape, but PyTorch wants something in this shape. So we're going to create something in 18.5.12. PyTorch wants something in 1.18.5.12. Now you could also just do this. That would sort of fix that. But often what I find is I generate a bunch of these and I grab, like let's actually say I made 20 W vectors, and then I might just grab the first one. And then the problem is that the first one is now in the shape of this. So unsqueeze is a tool unsqueeze is a function I use pretty much everywhere. This changes the shape from this to this. It just adds a dimension, and you have to say what that dimension is. So by saying it's 0, it's saying add the dimension here. If you were to say, I guess, 2, it would actually add the dimension to the end. But oftentimes you'll just use unsqueeze 0. If you actually look through the PyTorch code, you will see this pretty much everywhere. So let's run this really quickly. Yeah, so you'll see, I can comment this out. This is old stuff. So when I first ran this and I grabbed just the first version of this, or the first index of this stack, I got a shape of 18.5.12. Now, if I try to stick this into my PyTorch code, this would actually throw an error because it doesn't know how to actually do this. So what you really want to do is you want to Let's actually do this. This is kind of messy the way I wrote this. Let's do W0 equals W0 shape, and then we'll do W0 dot unsqueeze. Oh, that's okay. Let's do this. There we go. So now this is in the form of the correct. Basically, what this is this first number is the batch number. So how many of these am I sending to the model to process? So you always need the batch number in front of the vector number, or in most cases you do. This is a common area you'll run into. So all that to say, like, I don't know. This might come in handy later, or like as you begin to dig into the code, you might find this valuable. Second, you might actually want to combine these things in some shape or form. So let's say you've got, this is actually the code that we're using when we combine all of our MPZs from the projection code. The simplest way to combine a bunch of vectors is to actually just use torch.cat. That stands for torch.concatenate, I believe. So what you'll do is, now that I've changed my variable names, I gotta make sure you use the right variables. So what this will do is it'll combine these z values into a single tensor. And when we look at the shape, it should be 2, so a batch of 2, 18, 5, 12. One thing I note is you need to wrap these in a list. This is sort of one of the annoying things that gets really confusing. So you'll add this into this. Let's do that first. So there I have 2, 5, 12, right? So I took two vectors of a batch of 1 and 5, 12 and made them a batch of 2, 5, 12. Now in the case of something like the audio reactive notebook that really wants you to have 12 of those vectors, right? Let's say you actually don't have 12, but you just want to repeat them. Like let's say you have 2 or 3 and you want to repeat those. What you can actually do is use the torch.repeat function, and then you need to determine what index or what axes you want to repeat and which ones you don't. So in this case, what I want to do is I want to take this shape of 2, 5, 12, and I want to repeat this first axis 6 times. So what they'll do is it'll go torch Z, torch Z2, torch Z, torch Z2, torch Z, torch Z2. So it kind of have this repeating pattern. So when I run this, you'll see my shape is now 12, 5, 12. Now, it's important that you remember which axis you want to repeat and which ones you don't, because if you reverse these, now you've got a batch of 2 and a vector size of 3072, which is not good, or like not useful for what we would use this for usually in StyleGAN. So just a couple of notes there. One thing you might do, like one thing that I would probably recommend is if you have a bunch of projections, but you don't have 12, like let's say you have 6 projections, you might want to take those vectors and repeat them twice. That way you've sort of doubled them up. And finally, getting into what I think Varun is probably actually interested in, which is how do you load and save these? So the first way is you want to save a vector, right? So let's save our repeated vector to a file. And the way to do that is to do numpy.savez. Comment this out. So you'll run this. What this will do is it'll create a file, and that file will have in it saved our z's, our combined z vectors, saved to a key of z's. We'll talk a little bit about keys in just a second, but this is kind of helpful to know about. So we'll run this to save our file. Go over here, hit return. Now, one of the challenges with .mpz files is you can't just like double click on them and like open it and see all that data, right? It's not a JSON file, it's like a compressed file. So you'll get a bunch of gnarly stuff out of it. So usually the key here is to load these back in. Another note that I want to make here is that you can save more than just NumPy vectors into a .npz file. You can save notes and other things in here as well. So you can kind of think about these as like a saved file that you could then pull data from later. The way to add additional data is just to do more comma-separated lists after this. So in this case, I added something called notes. And I just sort of said like, hey, I made this file on June 23rd. So if I run this function, it'll just overwrite my z's file. But now this notes key has been added to this. And the way to load this back in is to actually use numpy at numpy.load and then read that file back in. And then the key here is that if you do this and you do just print test, you'll get something that says it's a numpy file, and you'll be like, okay, that's not helpful. I want to read the data out of this numpy file or out of this NPZ file. And the key for this is to just print out your test.file. The dot files will give you the keys available in that file. And so you'll see here that I have a key of Z's and a key of notes. And now if I want just the notes back out of this, you can do print and then do test notes. And if I print this, this will give me back this exact key. So this is kind of the funky part of using these NPZ formats is you can't just like load in the data and expect to get the vectors out. You actually have to know what the key is. So a common thing you will see here is you'll load in a projected file. Actually, let me do this. Let me grab, I have a file of projected pieces in here. A second, this drive is always slow to load up. So this is an NPZ file that I made previously using those combined projected vectors. So if I drag this into Colab, I can read in this file. So let me just read in combined NPZ into NP load. And what you might find is you might find one of these files and be like, what the hell was this thing? And then you want to remember what's actually in there, right? Like, is this a W file? What else is in there? So we'll run print projected.files. And then I believe in there will be a thing called W. And that's what all the W vectors are. And then I can look at it, see how many of them are actually in there. So yep, there's only one key. It's called W. And inside of there is a batch of 4 vectors, all in the shape of 18 by 512. So what you could do is you could take this, let's see. So this is, sorry for the number of tabs here. This is the Audio Reactor notebook. And if you recall, this is where we created a custom vector instead of our getLatents function. And what you could do here is you could actually remove all of this, just comment this out, and you could say load in projected vectors. And you could say projected equals MP load and then the W. So remember, this is in the shape of a batch of 4, and I need to be in a batch of 12. So what I could do is I could do projected equals projected dot repeat, and I want to do it 3 times on the first index and none on the others. And what I could then do is then I could take this and use this as the custom vectors variable. So this is pretty powerful because, again, I'm actually moving between my my version of PyTorch, like the PyTorch StyleGAN model, into one that is the Rosinality version. But because those vectors exist in both locations and ideally my model hasn't changed, you're able to move between those by just saving the vectors in and out. This is actually pretty powerful. I'm glad everyone asked about this. I know that for some of you that like Numpy torch thing is maybe a little boring, but hopefully it's been recorded in case you come back to it in the future and are like, I actually need that. So that's how I would do this. I know Varun isn't here, but he'll watch the video later. So this is how I would do this to save in this. And this is pretty short and pretty sweet to actually be able to do this. Any questions about that? That was a very quick, very brief introduction to some of the vector math we do, or I commonly do. Okay, well, last thing, I want to talk a little bit about just like some cases where you might actually use StyleGAN or not use StyleGAN. A couple people had asked me about VQGAN plus clip last week, and we're sort of like, can we do this with our StyleGAN model? And this is a good moment to also talk about, like, sort of for the end of the class, like, StyleGAN is great. I think it's really powerful, but it's not the end all be all. There are reasons why you might not want to use StyleGAN as your generator for various projects, including these clip-based notebooks. I think other models or other generators are much better at generating good imagery than StyleGAN would be. So as a reminder, the sort of pros of StyleGAN are that they're like, it's high resolution. Many other models don't go up to 1024 or larger. They go up to like 256, and I say, look at all the high res images we're able to generate at 256, and you're like, that's not high res. But a lot, so StyleGAN is very well structured to be able to do high resolution images. That's probably why we mostly teach in this class, because that's really interesting to artists, because we say 1024 is high res, and they're like, I can't print that. That's like a postage stamp if I print it. So, within the world of machine learning, StyleGAN is high res. The real challenge here, and I think that this is something that people are slowly sort of like unpacking or slowly beginning to understand, is that StyleGAN is often used for single domain image data sets. And by that I mean just faces, or just cat, or just whatever data you're using, right? It often needs to be aligned, so it generates this high resolution, like realistic looking imagery. And this is the biggest challenge of where I wouldn't want to use this for those clip generating notebooks, right? Because what clip is doing, or what a lot of those notebooks are doing, is they're generating from a vast vocabulary of words, and the idea is that hopefully it generates images that make sense for it. But if you were to say, like, show me, I don't know, a beach, a dog on the beach chasing a ball, and you use the FFHQ dataset, it knows nothing about dogs or balls or beaches. So it will very likely not ever generate good images. Whereas VQGAN, which is sort of more of a combined VAE and a variational audio encoder plus a GAN, I'll talk about that more in a minute. It's trained on a much bigger data set, and therefore it knows more images, therefore making it more applicable to something where you have a large vocabulary and trying to generate words from that. So this is the biggest challenge. There are some StyleGAN models that are trained on a bigger corpus of data, right? Like WikiArt or other things. But I also then find that their quality of output isn't as good. So this is probably the number one single reason why you wouldn't want to use that for stuff like clip. Now, we did look at using clip in a previous class with our StyleGAN model, but we sort of like bounded it to like, give me a person that looks like Elvis, right? We're sort of keeping it in that category of, well, faces, so maybe you know what Elvis looks like, or like we can generate an Elvis-like face. The other positive here is that there's all these layers of customization you can do, and that's really what we've been playing with a lot in this particular class. There's all these convolutional layers as well as the noise layers, and it offers you a lot of tips and tricks and techniques and customization options. And another big one that I would say that other models don't really talk about is this disentangled W space is actually really, really powerful at producing features that look good to the human eye, right? Not having glasses when you morph between two people without glasses is really powerful. I will say I have looked at VQGAN, and VQGAN has a very terrible latent space, is very messy, and you need to do some other tricks to sort of disentangle things. That comes a little bit between these two things, right? The more messy your data is, the more likely there is to be entanglement. And so like these two kind of play off each other. If you have a really clean data set, you're less likely to have a messy latent space. But the downside is it knows less data, essentially. So I probably talked about this a little bit, but like the cons of this, and the reason why you might not want to use this for something as diverse as using those clip notebooks, is the single domain is a really big challenge. It means it's going to limit the data that it's aware of. I have this idea, or like a concept of positional invariance, which I'm told isn't, or I've read is not true, but I still find it to be fairly true, which is like StyleGAN is not great at producing eyes that are down here at your chin. And it's just like it's not good at producing a beard that is like on your ear, right? We would call that positional invariance, right? The model doesn't know about spaces in places where it's not used to seeing them. That's kind of true, kind of not true. But it's just to say that the generator prefers things being in the right spaces or the right places, or it like is more likely to produce things in those spaces. So if you look at the clip notebooks or the image generators that people are doing with clip, with VQGAN or with Big GAN or other things, stuff tends to be all over the place. And my guess, which I could very well be wrong about, but like StyleGAN won't produce those images in those places as frequently or as well. And lastly, a common thing you'll hear is that people who are used to GANs, more simple GANs, or just other GANs in the world, will come in and look at the layers of StyleGAN and be like, what the fuck is this? Like, what are all these noise layers? What are all these like upscaling layers? Like, it's just a very complicated network. And it's taken a lot of people a number of years to sort of understand what each layer sort of does, how to manipulate each layer, these noise layers especially. So just like, it's a pretty complicated structure. So a lot of people will like, be like, oh, VQGAN, I can just pop that into my clip notebook. And then they'll go to StyleGAN and they'll try to pop that in and be like, wow, this thing isn't working. And I have no idea why. And I go through the architecture and it's very strange. So that is to say, like, part of the reason why I focus my class on StyleGAN is because of this. There's a lot of complexity. There's a lot of functionality that we can leverage. But the flip side of that is it is actually rather complicated to like mess with these individual layers. And I would say that was even more true when this was in TensorFlow because no one likes TensorFlow. Like TensorFlow is like a very hardcore sort of like developer language. Like people much prefer PyTorch because it's a little bit more readable. So there was that as also as a kind of side struggle previously. So you might hear people talking about GANs or talking about VAEs or about transformers. These are all three different types of generator models. GANs are, what we talked about, the generative adversarial networks. These are probably the most powerful in terms of realism today, although transformers are getting pretty close. And then there's also VAEs. I actually don't have anything about transformers here, but I might add that later. But VAE stands for Variational Autoencoder. Before GANs existed, this was what everyone used to generate images. And it generally generated these very blurry, sort of looking like averaged images. Like, you ever seen like an image done in like Photoshop or in some like image processing where they do the most averaged looking face or whatever? It's very blurry as it gets further and further away from the details. That's sort of what VAEs did. But I think this, actually, to go back, I found this a couple months ago, and I think this is a really great example of the difference between a GAN and a VAE. And I'll explain what this chart looks like in a minute, but it's just basically say that like GANs essentially are really good at realism in most cases, but do a bad job of more or less defining all of your data, whereas VAEs are much better at showing all of your data, but don't do a good job of generating like realistic images. So what we're looking at here is all these little dots. These are actually two graphs stacked on top of each other. So sort of like draw a little line here and split them off. At the top here, all these little dots are the data from your data set. The dotted line in the middle is your mean. So like the mean is sort of like what you would assume that like maybe like a really simple mathematics structure would find. And then in this case, at the top chart, the GAN is sort of what's being generated as we go through this. And what you'll see here is that in this location, it's doing a really good job of generating this data. And in this location, it's doing a very good job of generating this data. You could describe it as overfitting and or realism. But then you've got these little jumps where it jumps across this. And in these locations, you would probably get really bad images. This is kind of like this is like a scaled down version of what is realistically happening in a GAN. So this tells me that like it's really good at modeling this data, maybe these photographs or these photographs, but it's really bad at generating these photographs. So you could describe this as almost like mode collapse, which is why I think a lot of us see these challenges in like, hey, I've got some really interesting data in my data set that never shows up in my GAN. Why is that? This is why. Because it's sort of overfitting to certain parts of the data, but it's missing entire other parts of the data. This is just a thing that GANs do. GANs are generally known as like, the joke is that they will overfit, or their goal is to overfit to basically generate realistic images. And this is why we have that adversarial function to sort of keep them a little bit less overfitting, but they still do overfit. Whereas a VAE, a variational autoencoder, does a much better job of being distributed across the entire data set. But you'll sort of see that like it doesn't focus in any one area too much, right? It kind of focuses over here. But like what that says is that this image isn't going to be perfect. It's not going to look real, or it's going to look like kind of blurry or like not as focused. And this has always been the big challenge of generative models. This is just like, well, do you want this where you can't get the whole data, or do you want this where you get the whole data but it's like not like perfectly accurate? So VQGAN, which is sort of the model that a lot of people are using today for the clip notebooks, is actually kind of a mix of the two, I believe. I'm not super familiar with that model, so I shouldn't speak too. Shouldn't be holding my opinions too strongly about that, but it's generally like it's a mix of those two, and it generally performs a little bit better in being both realistic and generating more like more average data. And I believe it's actually a transformer model, which I don't really have covered here. Transformers are sort of the new hot thing that people are working on, but they tend to incorporate like mixes of all these data types. Cool. So that was just a couple like little sort of follow-up things about like StyleGAN as a whole, and sort of like to finish off the class to give you a little bit of idea of things you might want to look at. So you might want to take a look at VQGAN next, or you might want to look at VAs and sort of see how they play out. Yeah. So homework for this week, play with the rewriting model. Maybe try porting over your projections from the projection notebook into Audio Reactive using the tools or the code that I said, and then fill out that poll. I just didn't end the sentence. Fill out the poll for the show and tell. Just gonna edit this real quick if you'll let me. Cool. So I've got about 15 minutes, so I can go back into, I can sort of show the GUI with my 1024 model if anyone's interested, but I can also answer questions if anyone has anything. This is obviously the last week class, so like we won't have anything additional for this. And I probably will be taking the rest of the summer off from teaching, just because teaching 2 or 3 classes pretty much nonstop through the pandemic has left me a little burnt out. There's some art projects I actually want to work on myself. So I'm going to take the next couple months off to do that. And I'll probably be teaching again in the fall. And I'm not sure exactly what I'll be teaching. So if anyone has requests and or just interested in something, like please let me know. I tend to do a mix of like basic classes plus doing more of these advanced classes. I really like teaching these advanced classes, but it's not everyone can take them. So I was just gonna say, yeah, I'm probably gonna try to teach some more basic classes in the fall, but if there are any advanced courses or anything that people are interested in, let me know and maybe we can cover some of that. So I guess with that, are there any questions before I jump into showing the GUI on a 1024 model?
Not a question, but more so a comment or a request. I'd be interested in doing like shorter workshops, maybe. I know you did one, that like coding one, something like that. Maybe I'd be interested mostly because of my schedule. It's like kind of nice to fit it in like one of the weekends, and sometimes it gets a little hard to commit to like multiple weeks in a row, right?
Yeah, that's a great point. Yeah, maybe I'll think about doing some of those as an offset to sort of doing some more basic classes for newer folks. I think that'd be a good idea. Yeah, it's great.
Yeah, I'd second that. Particularly during the school year, it's hard for me to, find the time.
For sure. Cool. Yeah, I'll definitely think about how to do some of those. And I think Leo will be back after the summer too, so we'll have maybe a couple of people be able to operate on stuff like that. And if there is anything in particular that you are interested in doing over a workshop, like please let me know. I'm happy to. Those can be a little bit more loose or like just like be a little more focused, right? So we could think about that. One thing that's been on my list to do is actually to do a class about how to convert models into Runway. So basically, if you find a model on the internet that you can use, you can bring it into Runway. I've been thinking about doing that. So that's on my list of maybe things to do for later this year.
Did you record a video for that? Or am I making it up?
Not really. I mean, it's not that hard to do actually, but it's just like you sort of have to go through a certain process. And I haven't recorded a video for that yet. Although I do have a video on how to like bring an old StyleGAN model into Colab using GitHub, but that's kind of out of date at this point, I would say. All right, if there aren't any other questions, I will switch over to sharing my Linux screen, and we can sort of play with a GUI model at 1024 and sort of see how this goes. All right, are y'all seeing a Finder window that is not a Mac window? Cool, great. Okay, so this uses a Jupyter notebook. Again, Jupyter notebooks are essentially the same thing as Colab. Like Colab just uses Jupyter under the hood, but it's a little different because it's a different interface, and you have to run it locally from your local computer. So what I will probably do is I'll record a tutorial on how to do this, but run it through Paperspace, in part because I don't expect everyone to have a Linux machine. That is pretty crazy. And Paperspace is kind of expensive, but for a process like this, not that bad. So Paperspace generally costs about 75 cents an hour. So because we won't be doing training doing this, it's kind of you can use it and like run stuff that way, and it'll still work for your larger model. The challenge will just be to like move stuff in and out, but I'll record all that in a tutorial to get this up and running. But essentially, like once you've got it up and running, which might take 30 minutes to get started, then it operates pretty much almost exactly like Colab, and you'll just be doing it directly from the Jupyter notebook. So it's a slightly different look, but it's like the same process. So you run these cells using shift return. I'm going to keep typing in the wrong keyboard here. So you'll see that I've got 3 GPUs already set up here. So by default, it's just going to use, I think, whatever the biggest one is. And the challenge I was facing with running this on Paperspace is it couldn't actually find my GPU, so I need to fix that. But essentially, this process is all the same here. Make sure we're in the right folder. Let me actually just do this. Make sure I'm in the right folder. Now I'm not, so I want to go CD, rewriting. Okay. So I'm going to skip this section. This is how to use the default. So if you want to use the default faces, I could make sure this runs. I'm going to skip down here and actually show how to load in my own model. So all I've done here is I've added a little bit of detail in these things. So the line to look for in this is stateDict equals torch.load, and then pass in the path to your model. So what you'll need to do is you'll want to download this model into, I guess, your Paperspace account, and then copy the path of it. So in this case, mine is in downloads, and then here I've got a file called FreeGAN, and I'll copy this. Oh, the other thing, I forgot to mention this before. The other thing is, if you've previously created your .pt model, the Rosinality version, let's say if you created it prior to maybe a week ago, rerun that notebook that says how to do the conversion. There's an additional thing I need to add to that model to make sure that we're saving out what's called this latent average. So I'll paste a link to the updated notebook in case you lost it. That updates this. So you'll want to rerun that before you download this model. So here we'll just update this, and then I've updated a couple paths in here, which again, I will probably clean up this notebook a little bit more just so people can use it, and it'll be a little bit nicer. So I basically have renamed some of these folders. Now this is set up here, I can just go ahead and run this. Also, I'm working on layer 10. For whatever reason, this model seemed better with layer 10 than with other layers, so just go ahead and run this. Because the interface is a little different, you don't get a like spinning play button. You get this little asterisk, and that means it's running. All right, cool. So now I have my GUI down here. So why don't I just try to recreate that removing of the yellow triangle. So what I'll do is I'll go in and I'll just paint in this little yellow triangle. I'll go add to context. See if I can find any other ones in this set. There's another one. context. And there's another one. And now I've got a couple in here. I'm going to go and search again. All this stuff is a little slow to update. That's just like, I feel like the world of machine learning will be a lot nicer in like 3 years when there will be no slow updates. It'll just like automatically give you exactly what you want back real time. All feel a little bit nicer that way. So I'm just going to add a couple more of these to context, but you'll see like these are loading in some additional yellow triangles here.
This process will be fast enough, but like they'll be like, you know, like the 8K models and they'll run like this. Yeah.
Yeah, exactly. So there'll still be other things that will run slow, but we'll have slightly nicer GUIs. I actually just say like, as much as I sort of like, you know, made fun of this clearly being designed by a developer, this is not the nicest GUI I've ever seen in Colab. Like I went through the code and there's a lot of code to make this thing happen. So like, I'm pretty impressed that this actually works the way it does. But yeah, it's, you know, again, not my favorite. Okay, so I've got a bunch of yellow triangles here in my context. So now let's go ahead and I'm just going to go back to my original set of images and grab something to paste in. So let's try to maybe grab something a little bit different. Maybe we won't grab in. Maybe let's grab let's try grabbing something red instead. So instead of doing the I think previously I'd done a blue, like trapezoid, I want to grab this red shape. Oh, that's interesting. Let's paint in this. We'll copy this. And then we'll go back down and click our little yellow guy here. And one thing I should also note is you'll notice that my GUI is a little different and that I'm not actually seeing all those outlined shapes and stuff. It's because I went in and hacked this notebook or went in and hacked the code here. So I don't actually get that. The reason I did that is because I wanted to be able to actually grab these images. Like if I like what this image looks like, I wanted to be able to grab this image. And actually be able to save this. So this is kind of like hacky. I would love if maybe in the future I could actually like figure out how the code, I have to say like the code for this is it's very different than anything I've seen before. So I'm really interested to sort of like dig into this code maybe more over the next couple weeks to sort of see what's actually going on here so I can play with this more. But I sort of hacked around just so I can like save out individual images. The challenge with this is like, again, as I think I mentioned this is a single image that is not really any part of my model. So like, this is basically Photoshop. It's like giving me an image, but it's cool. But it's I can't like get this image out again. So I've gone ahead and like done this copy and paste thing. Let's go in and actually just execute this. So what I like to do is I click search. So I make sure I get all of my good images or all the images that sort of match this like yellow triangle thing. So lots of yellow triangles here. So I'm gonna go ahead and hit execute change. There we go. So now it's removed. It's sort of converted in many cases that yellow triangle to something reddish. So if I go here and I hit toggle to original, you'll see there were all my yellow triangles. And now I toggle back. They've all been sort of changed into red. And you will see there's a little bit of entanglement, right? Like some other things are changing. But for the most part, this is pretty good. Like this overall generally pretty much works. So I think this is pretty powerful. Like I'm definitely probably going to spend a little bit of time this summer digging through this code and trying to like edit some of these things. So hopefully I'll make this a better tool maybe in the next couple of weeks. So it's actually even more useful. But again, then you can go in here and you can save up your vectors. You can download these files, enter the code for downloading the model. But you can actually generate a bunch of images using this. So it's pretty interesting. obviously the challenge of like, or the fact that it doesn't work in a 1024 model on Colab is kind of annoying. Maybe I'll figure out how to fix that before I even do this stuff. But yeah, it works pretty well, and I find it's very interesting for stuff like abstract models. Now I will say I had a lot of challenges. I was trying to do some crazier stuff. Like I was trying to take some of those like more gridded images and take some of the grid and paste it in the middle of these shapes, and that sort of like blew up my model. Maybe I was just operating on the wrong layer. So again, there's still a lot of manual process to do with these. But I think we're beginning to see like the beginnings of more control, the beginnings of more like Photoshop filter almost like features within these things. So I think you know, next year or two of these tools is gonna be really powerful and really cool. So that's what I've got for the rest of the class. So again, please, if you are interested in attending show and tell, like please fill out the poll and make sure that you sign up for a time that works for you. I would say try to find many times that work for you if you can. Like, you know, just be as open as you can, and then that way, if I'll try to find a time that works for the most people. And if it doesn't work for you, like please do think about recording a video and sharing that with me. And again, we will keep doing co-working sessions, so I'll keep posting the Slack channel whenever we have an open co-working session. So if you have questions or if you're working on a project and want to attend, you can. And so I hope I see you either there or in show and tell. And if not, I hope you at least enjoyed this class or got something out of it. I'm always welcome to feedback. So if you want to just like DM me and say like, hey, I think you went too fast or like did too much or too little, or I was expecting this and got this. I'm always welcome to take that into future classes. So any other questions before we call it a day? All right, well, I'll at least talk to most of you over Slack over the next week or two, and hope to see some cool stuff made in show and tell.
Thanks very much, Derek, for everything. And
Yeah.
thanks to all of you for tolerating my Sophia sides and other BS. Hope it hasn't been too much of a bore.
Totally fine. I love it. All right. Thanks so much, everybody.
Thanks.
Thanks, Derek.
Yep.
Thanks so much.
Yeah.
Bye, everybody.